Hello everyone, welcome back to our channel. So in this live we are going to see our daily challenge on Leetcode platform. So what is our Leetcode problem today? So find all possible stable binary array 1. So this is a medium range problem. So now what we are going to see, so we have our problem. You are given 3 positive integer, that is 0, 1 and 1 limit. So a binary array is called stable if the number of occurrence of 0 in array is equal exactly 0 and the number of occurrence of 1 in array is exactly 1. So each subarray of array with a size greater than limit must contain both 0 and 1. So return the total number of stable binary arrays. So see what our example says. We have 0 equal to 1, there must be 0 equal to 1 and 1 should be 1 and the limit is 2, right. So how many possible array we have got here? That is 2. So see here we have got one explanation. The two possible stable binary are 1, 0 and 0, 1, as both array have single 0 and a single 1 and no subarray has the length greater than 2. So first let me explain the what is this question. So this is our question, right. So what's this problem say? We have this 0, right. We have this 0, that means it represents number of 0. What it represent? It represent the number of 0. Then what my 1 represent? It represent number of 1s. So this represent my number of 1s and 1 represent number of 1s. Then what my limit represent? My limit represent maximum same numbers allowed continuously, right. So my limit represent maximum same numbers that are allowed continuously, right. Okay. Now we will write a pseudocode for this problem. Okay. So see, if we have example like here we have write 0, 1 and limit. So let us take another example like my 0 is equal to 2, 1 is equal to 1 and my limit is equal to 2. Okay. We must create an array using 2 zeros and 1 1, right, and only 1 1. But we cannot put more than 2 numbers together. We cannot put 2 same numbers together. So what's our valid array means? 0 0 1, 2 zeros and 1 1, then 0 1 0, 2 0 and 1 1, 1 0 0, 2 0 1 1. So this is our valid arrays. So how many arrays we have here? 3 arrays, right. So our output will be here 3, right. So now we will write pseudocode for this problem, right. So first what we are going to do? We are going to use DP for this problem, right. So we are going to use DP for this problem. DP means you know, right, dynamic programming. So first I will take one long. Why I am taking long here? Because our answer will be, it may be comes in long, so we are using long. So I am taking one long, new long. Then first my 0 0, how many 0 I am taking that array, then the size of 1, then the size of my limit, right. So here I am taking the limit, that is 2. So why I am taking a 2 means my last number will be always either it will be 0 or 1, right. So if you see here the last position, so it is always whether it is 1 or whether it is 0. So here I am taking 2 because of that reason, right. Okay. Now what I am writing? Next, my dp of 0 of 0 equal to 1 I am taking, right, and dp of 0 of 1 equal to 1. So what does this means? So this means there is no zeros and there is no ones, right. So I am taking this base case because I am replacing there is no zeros and there is no ones. So that means only empty array exists. So I am taking way equal to 1, right. So number of ways equal to, first I am taking 1. Then what I will write? First I will loop through my zeros. We have zeros, right, in question. Zeros equal to 2, ones equal to 1. So first I am loop through my 0. So for that int I equal to 0 and then I less than or equal to 0, then I plus plus. So first I am looping through the 0. So it will try all the possibilities, right. So if I given zeros equal to 2, what and all the iterative it will have? First it will iterate 0 zeros, then 1 zeros and then 2 zeros. Why it also taking 2? Because I have given equal to, right. So it will also take 2 zeros. Then what I am going to write? Loop for ones. So for int j equal to 0, j less than or equal to 1 and j plus plus, right. So what it will tries? It tries all the possibilities of 1, that is first 0 ones and then 1 ones, right. Next I am taking loop for int k equal to 1, k less than or equal to limit. So I am taking this loop for limit, right. So how many limit we have? We have limit equal to 2, right. So for why we are taking this limit loop? This checks how many same numbers we add together. So this loop checks how many same numbers we add together. So example, if my limit is 2, right, my limit is 2. So we can add 1 0 and 2 zeros, right. That means we can write 1 or 2 zeros, but not 3 zeros, right, because our limit is only up to 2. So we can write 1 0 or 2 zeros continuously. So for that we are giving this limit loop, right. Then what I am going to write? Okay, wait a second. Now we will write the code for adding the zeros. So adding the zeros in array. So this line is for what? Adding 0, right. So this line is for 0 loop. So this is for ones loop and this is for limit loop, right. Okay. Now we are going to write a code for adding zeros in the array. Okay. Now if my I, that means zeros minus limit, is greater than or equal to 0, then what I am going to do? dp of I of j of 1 plus or equal to dp of I minus k j of 0. Don't worry if you don't get anything, we will see. Okay. So what does this line means? So means we add k zeros in our array, right. So, before adding these zeros, previous must be 1, right. So, before adding this 0, the previous number must be 1. So, what does this means? So, if we have like numbers and we have 1, right. So, if we have previous number as 1, then we will add 2 zeros to it, right. If we added front itself, the 0 will exceed limit. So, we are checking before adding this 0, the previous number must be 1. Then only we add this 0 to that array, right. Okay. So, this if is for adding zeros, right. Then for adding ones. So, for adding ones, what is the code? So, same like adding zeros, j minus k is greater than or equal to 0. Then what we are going to do? dp of I of j of 0 plus or equal to dp of I of j minus k of 1. So, means we will add k times 1, right. We will add k once in the array. This if will add k ones to the array. So, before that array should be ends with 0. If the array is ends with 0, we will add 1 to it, k ones to it. If the array is ended with 1, we will add k 0 to the array. Understood? So, if the array is ended with 1, then we will add k zeros to the array. If the array is ended with 0, we will add k ones to the array, right. Okay. Now, what we are going to do? This is our pseudocode, right. Now, finally, what we will return? We will return at the last. So, return int, because it will be a very long number, right. So, we are returning int. The function has asked to return in the integer type. So, at finally what we will return? So, dp of 0, the question they have given, right, 0, 1's limit. So, dp of 0, 1 and of 0, then plus dp of 0 of 1 of 1 modulus mod. So, I will tell why we are using this mod, right. So, this is our pseudocode for our problem. So, we build the array step by step, right. So, first what we have done? So, we have start our array as empty. We have start the array empty, right. So, we have start array as empty. Then we added zeros, and we added the ones, but we never exceeded limits, right, because dp remembers previous combination. So, we do not need to calculate again, right. So, for that only we are using the dp, right. So, this is our pseudocode for our problem. So, up to this I hope you understood. If you have any doubt, let me see in the chats. So, now we will try to code it in Leetcode. So, first what will happen? What we are going to write? We are going to first write one long dp array. Then we are going to start it with empty array. Then what we are going to do? For 0 we are writing one loop, for 1s we are writing one loop, and for limit we are writing one loop, right. then we are adding zeros to the array, k zeros, k times 0 we are adding to it, then we are adding ones to that. If the array is ended with 1, we will add k0 to the array. If the array is ended with 0, then we will add k ones to the array, right? Okay. Now we will try to code it in the Leetcode. Then we will check whether our approach is correct or wrong. Okay. First, what we want, we will take, we are going to use Java for this question. If you are comfortable with any language, you can use any language. So first I am taking int mod equal to like one big number, because it will reduce the large number to smaller number. So it will avoid the overflow, right? So I were using this mod to require the overflow of that. So first one, long dp equal to new long of, first what we are going to write here, 0 and in the size of 0 plus 1, and in the size of 1 plus 1, and in the size of 2. So why we are written here 2? Because our last row will be in 0 or maybe 1, right? So it will be in the 2 condition, if it is 0 or it may be 1, right? Okay. Then what we are going to write? Then dp of 0 equal to 1, then dp of 0 of 1 equal to 1. So why we are taking it? Because we are starting from empty, there is no zeros and there is no ones. Okay. Now first we are going to write loops for zeros and ones and for limit. So my 0 loop will start from 0 and it is less than or equal to 0. So how many iterative it will pass? Up to zeros. If the zeros is 2, it will iterate 0, 1 zeros and 2 zeros, right? Then for ones, int j equal to 0, j less than or equal to my 1 and j plus plus. Next, for limit, right? So k equal to, it starts from 1 and then k less than or equal to limit and k plus plus. So the k will be either, it will run up to limit, right? So what next, what we are going to do, we are going to add zeros to our array, k times 0 or k times 1 we are going to add in our array. So for that, what condition we have written? If my I minus k that is equal to 0, greater than or equal to 0, then what we are going to return? dp of I of j of 1 plus or equal to dp of I of j of 1 plus dp of I minus k and then j of 0. Then what I am doing to here? I will be modulus it with mod. We have taken here mod, right? So what I said, why we are using this mod? To prevent the overflow, right? To prevent the overflow of the large number, we are using this mod. Then after completion of adding the 0, then what we are going to do? We are going to add add the ones, right. So, what we are going to check, j minus k, if that is greater than or equal to 0, what we are going to do, we are going to add in our array, right. So, dp of I of j of 1 and equal to dp of I of j of 0. So, here also it is 0 because we already added 1 in that. So, now plus dp of I of j minus k and of 1. So, already I said, right. So, in our last row it will either 1 or 0. So, only we have written here 0 and here 1. Then modulus mod. So, I have written here mod to prevent the overflow, right. So, to prevent the overflow we are writing here mod. So, after completion of adding the ones, what we are going to return? We are going to return integer type of dp of our 0 and 1s and then first 0, then plus dp of 0 of 1 and then of 1, right. So, 0 then plus 1, right. So, then modulus mod. Why we are writing this mod? To prevent the overflow. So, this will return the integer, right. So, our question asks to return in the integer type. So, we are returning it in integer type, right. So, first what we are doing? First we are creating one long dp array, then in the size of 0 plus 1, then 1 plus 1 and 2. Why we are written here 2? Because our last element would be either 0 or either 1. Then we are creating dp, the 0th element 1 and 0 of 1 equal to 1. Why? Because we are starting from the empty array, because there is no zeros, no ones. So, then this loop is for zeros and this loop is for 1 and this is for limit, right. So, starting from 1, because the limit will be starting from 1. So, we are writing 1. Then we are writing this if condition to add the zeros to our dp array. Then we are writing this if condition to add ones to the dp array. So, this will add k times 0 and this will add k times 1, right. So, after completion we are returning the addition of our 0 of 0 and 0 1 of 1. So, we will run this whether our approach is correct or wrong. So, here I think I maybe missed one number. So, hopefully our test case has passed. So, for 1 zeros and 1 1 limit should be 2, the output will be 2. So, here already they have given. So, the possibility is 0 1 comma 0 or 0 comma 1. Then the second test case is there can be 1 0 and 2 1 and the limit should be only 1. So, the output will be 1 and with the number like see here 1 0 1. If we write like 1 1 0 or 0 1 1, it may have the subarray of length 2, because here same number is continuously occurred. See 1 1 and here also 1 1, but our limit should be only 1. So here the possibility is only 1. So I hope you understood this problem. We try to submit this. So we have submitted our problem and it has submitted. So the time complexity is, so first we will take the, let the 0 as 0, O1, and our zeros for loop will be runs how many times? It will be runs 0 plus 1 times, right. So it will run 0 plus 1 times, and our once loop will be runs 1 plus 1 time it will run, right. Then our limit will be run limit times. So how many limit it has? It will run limit times. So if we calculate, our final complexity will be, what our final complexity? O of 0 into 1 into limit. So this is our complexity. So if our space complexity, we think our space complexity will be, we used long DP, right. So the memory used is 0 plus 1 and the size of 1 plus 1 and 2, right. So into 2. So the final complexity will be O of 0 into 1. Next, see if we take one example like 0 equal to 100 and 1 equal to 100 and my limit is equal to 100. Then what will be my optionally rough means? It will 100 into 100 into 100, that is equal to 10 lakh, right. So the time complexity should be big O of 0 of 1, big O of 0 into 1 into limit. The space complexity will be 0 into 1, right. So you understood this problem. So now I hope